Right now, the atmosphere is changing rapidly, and meteorologists are becoming increasingly concerned. A powerful storm system is moving in, energy is building in the atmosphere, and the ingredients for a potentially dangerous severe weather event are coming together. Large hail, destructive winds, intense lightning, and even the possibility of tornadoes could all be part of this developing situation. The signals in the atmosphere are becoming stronger by the hour, and what happens next could impact millions of people. In this video, we're going to break down 7 critical warning signs that show why this severe weather threat is rapidly escalating. 1. The atmosphere is becoming highly unstable. To understand why today's severe weather threat is escalating so quickly, we need to start with the most important ingredient in any major storm setup: atmospheric instability. Right now, the atmosphere is essentially storing a tremendous amount of energy. Near the ground, warm and very moist air is spreading across the region. This type of air is lighter and naturally wants to rise, but above it sits a layer of cooler, denser air. When this situation develops, the atmosphere becomes stacked in a way that is primed for explosive storm development. Think of it like a tightly compressed spring. The warm air near the surface keeps building energy, waiting for the moment when something finally forces it upward. Once that release happens, the rising air can accelerate rapidly into the upper atmosphere, and when that process begins on a large scale, thunderstorms can grow extremely tall and powerful in a very short amount of time. Meteorologists measure this energy using a value called convective available potential energy, often shortened to CAPE. When CAPE values climb high, it tells forecasters that the atmosphere has plenty of fuel available for strong storms. The higher the number, the more powerful those storms can potentially become. In the current setup, that instability is continuing to increase. Warm air is being transported northward, moisture is building, and the atmosphere is becoming more volatile by the hour. This means any storm that manages to develop has the potential to rapidly intensify. And that's where the concern really begins. When the atmosphere becomes this unstable, thunderstorms are no longer ordinary. They can produce towering cloud structures that reach tens of thousands of feet into the sky. Inside those clouds, violent updrafts can form, lifting rain, hail, and ice high into the storm, where they grow larger and more dangerous. This type of environment is often the first sign that a severe weather outbreak may be on the horizon. It tells meteorologists that the atmosphere is fully capable of supporting strong storms. All it needs now is a trigger to set everything in motion. And as we move into the next lesson, we're going to talk about another critical ingredient that can turn these storms from powerful to potentially dangerous. 2. Wind shear is increasing. While atmospheric instability provides the fuel for severe storms, there is another ingredient that determines how dangerous those storms can become. That ingredient is wind shear. Wind shear refers to the change in wind speed and wind direction as you move higher into the atmosphere. At the surface, winds might be blowing from one direction at a relatively modest speed, but several thousand feet above the ground, those winds can be moving much faster and sometimes from an entirely different direction. This difference in wind speed and direction creates a powerful effect inside developing thunderstorms. As warm air rises rapidly through the storm, the changing winds begin to tilt and organize that rising air. Instead of storms collapsing quickly after they form, wind shear allows them to remain structured and long-lived. When wind shear becomes strong enough, thunderstorms can start to rotate. This rotation is what transforms an ordinary thunderstorm into a supercell, which is the most powerful and dangerous type of thunderstorm that can develop in our atmosphere. Inside a rotating storm, the updraft becomes extremely strong and organized. Rain and hail can be held up inside the storm for longer periods of time, allowing hailstones to grow larger. Winds can intensify as the storm structure strengthens, and in certain situations, that rotating motion can extend downward toward the ground, potentially producing tornadoes. Meteorologists are closely monitoring wind patterns throughout the atmosphere right now, and the signals are becoming increasingly concerning. Winds higher up in the atmosphere are strengthening significantly, and the direction of those winds is shifting as well. This combination creates the kind of wind shear that severe storms thrive in. What makes this setup particularly dangerous is the interaction between the instability we discussed earlier and the strengthening wind shear. Instability allows storms to grow tall and powerful, while wind shear organizes those storms and allows them to persist. When both ingredients are present at the same time, the potential for severe weather increases dramatically. This is why forecasters are paying very close attention to the evolving wind patterns. The stronger this wind shear becomes, the greater the chance that storms developing later could organize into powerful, rotating systems capable of producing significant impacts. And as we move into the next lesson, we'll look at the large-scale weather system that may act as the trigger that sets these storms into motion. 3. A powerful storm system is moving in. Even when the atmosphere is extremely unstable and wind shear is strong, severe storms usually will not develop without something that forces the air to rise. This is where the larger storm system comes into play. Right now, a powerful weather system is advancing into the region. These systems often form when large areas of low pressure move across the atmosphere, acting as a driving force that lifts warm, unstable air upward. When that rising motion begins, it can quickly unlock all of the energy that has been building near the surface. As this system approaches, it begins to change the structure of the atmosphere. Pressure starts to fall, winds begin to shift, and the lifting motion becomes stronger. This lifting process is critical because thunderstorms need rising air in order to develop. The stronger the lift, the easier it becomes for storms to form and intensify. In many severe weather outbreaks, the arrival of a strong storm system acts like the spark that ignites everything. The atmosphere may already be primed with instability and wind shear, but once this larger scale trigger arrives, thunderstorms can suddenly erupt across a wide area. Meteorologists are watching this incoming system closely because it has the potential to organize storm development along specific boundaries, such as cold fronts or dry lines. These boundaries are often where storms form first, and once they begin, they can rapidly grow into clusters or powerful individual cells. Another important factor is timing. When a strong storm system arrives at the same time that instability and wind shear are at their peak, conditions can align in a way that supports significant severe weather. Storms that form in this type of environment can intensify very quickly and produce a variety of dangerous impacts. This approaching system is expected to provide the lifting mechanism needed to start storm development. Once storms begin forming, the unstable and sheared atmosphere we discussed earlier will determine just how intense they become. 4. Moisture levels are extremely high. Another critical ingredient in this developing severe weather setup is the amount of moisture currently present in the atmosphere. Moisture is often overlooked by people outside the weather community, but for meteorologists it is one of the most important signals that storms could become powerful. Right now, the lower levels of the atmosphere are becoming saturated with warm, humid air. This moisture is being transported into the region by steady winds flowing in from warmer areas. As this air moves in, it increases humidity near the surface and adds more fuel to the developing storm environment. Moisture plays a major role in how thunderstorms grow. When warm, humid air rises into the atmosphere, the water vapor inside that air begins to condense into clouds and precipitation. During this process, heat is released into the surrounding air. This released heat acts like an extra boost of energy that strengthens the storm's updraft. The stronger the updraft becomes, the taller and more powerful the storm can grow. These powerful updrafts can carry water droplets, ice particles, and hailstones high into the upper levels of the atmosphere. Once there, those particles can continue growing before eventually falling back toward the ground. High moisture levels also mean storms are capable of producing extremely heavy rainfall. In some situations, thunderstorms can release large amounts of rain in a short period of time. When that happens, drainage systems can quickly become overwhelmed, increasing the risk of flash flooding in vulnerable areas. Meteorologists monitor moisture using measurements such as dew point temperatures and atmospheric moisture content. When these values rise significantly, it signals that the atmosphere is becoming increasingly supportive of strong storms. In the current setup, moisture levels are climbing rapidly, which means thunderstorms will have plenty of fuel to work with once they begin to form. Combined with the instability and wind shear already in place, this moisture adds another layer of concern for forecasters. As we move into the next lesson, we'll examine what can happen when all of these ingredients combine, leading to the development of some of the most dangerous thunderstorms on Earth. 5. Supercells could form when instability, wind shear, lift and moisture all come together in the same environment. The atmosphere becomes capable of producing one of the most powerful types of thunderstorms known to meteorologists, the supercell. Supercells are different from ordinary thunderstorms. Most storms produce rain for a short period of time and then quickly weaken as their internal structure collapses. Supercells behave very differently. They develop a highly organized structure that allows them to survive for hours while continuously producing severe weather. The defining feature of a supercell is a rotating updraft. Instead of air simply rising straight upward, strong wind shear causes the rising air inside the storm to begin rotating. This rotation creates a persistent, powerful core within the storm that helps maintain its strength over long periods of time. Because of this structure, supercells are capable of producing some of the most intense weather events on the planet. The powerful updrafts inside these storms can lift hailstones high into the atmosphere again and again, allowing them to grow larger each time they cycle through the storm. By the time they fall to the ground, hailstones can reach damaging sizes. Supercells are also known for producing destructive straight-line winds. As rain and hail fall through the storm, they drag cooler air downward toward the surface. When that air spreads out across the ground, it can create sudden bursts of powerful winds capable of causing significant damage. Perhaps the most concerning aspect of supercells is their potential to produce tornadoes. The rotating motion inside the storm can sometimes tighten and extend toward the ground, forming a tornado. Not every supercell produces a tornado, but nearly all of the strongest tornadoes come from this type of storm. Meteorologists pay close attention whenever the atmosphere becomes supportive of supercell development. The ingredients we discussed earlier, instability, strong wind shear, rising motion and high moisture, are exactly the conditions that allow these storms to form. In the current setup, the atmosphere is beginning to show many of the signals that favor supercell development. If storms begin forming within this environment, there is a real possibility that some of them could quickly organize into powerful rotating thunderstorms. In the next lesson, we will examine another major concern with this weather setup: how rapidly these storms could intensify once they begin developing. 6. Rapid storm intensification. One of the most concerning aspects of this developing weather situation is not just the potential for storms to form, but how quickly those storms could become severe. In many dangerous weather setups, thunderstorms do not gradually strengthen over several hours. Instead, they can intensify at an alarming pace. Rapid storm intensification happens when all the atmospheric ingredients we've discussed are already in place before storms even begin. The instability provides a large reservoir of energy. The wind shear organizes the storm's structure. The moisture fuels powerful updrafts, and the approaching storm system provides the lift that starts the entire process. When storms begin forming in an environment like this, they can tap into that stored energy almost immediately. Within a short period of time, a small thunderstorm can grow into a towering system, reaching tens of thousands of feet into the atmosphere. During that growth phase, the storm's internal circulation can strengthen quickly, allowing severe weather to develop much faster than people expect. This is one of the reasons meteorologists take these setups very seriously. When storms intensify rapidly, warning times can become shorter. A storm that initially appears weak on radar can quickly evolve into something much stronger as it organizes and begins to rotate. Inside these strengthening storms, powerful updrafts can develop that carry rain, hail, and ice high into the storm cloud. As these particles circulate through the storm, they grow larger and heavier, At the same time, strong downdrafts can develop as cooler air and precipitation rush toward the ground. When these downdrafts spread outward at the surface, they can produce sudden bursts of damaging wind. Rapid intensification also increases the chance that storms may transition into organized severe structures, such as supercells or clusters of strong thunderstorms. Once storms reach that stage, they can maintain their strength for extended periods and produce multiple types of severe weather. Forecasters are watching this situation carefully because the atmosphere appears primed for this type of explosive development. If storms begin to form under these conditions, they may not take long to become dangerous. In the next and final lesson, we'll look at why meteorologists are concerned that this situation could evolve into a widespread severe weather outbreak. 7. This could become a major severe weather outbreak. At this stage in the setup, meteorologists begin asking one very important question. Is this just a few isolated storms, or could this become something much bigger? Right now, the concern is that the atmosphere may be preparing for a widespread severe weather outbreak. And when forecasters use the word outbreak, they are talking about a situation where numerous severe storms develop across a large region within a relatively short period of time. This type of event does not happen randomly. It occurs when several powerful atmospheric ingredients align at the same time and across the same area. Throughout this video, we have talked about those ingredients: instability, strong wind shear, deep moisture, a powerful lifting mechanism, and the potential for organized rotating storms. What makes this situation concerning is that all of those ingredients are beginning to overlap. The atmosphere is becoming increasingly unstable, meaning storms that form will have access to large amounts of energy. Wind patterns high above the surface are strengthening, which allows thunderstorms to organize and persist longer than normal. Moisture levels continue to rise, providing the fuel that allows storms to grow taller and stronger. And now the approaching storm system is moving closer, providing the trigger that could set everything into motion. When these conditions come together over a wide region, the result can be a chain reaction of storm development. Instead of one storm forming and dissipating, multiple storms can begin developing along weather boundaries, such as cold fronts or lines of converging winds. These storms may start as individual cells, but as they grow and interact with the environment around them, they can organize into larger storm clusters or powerful rotating systems. And once storms become organized in this type of environment, they can travel long distances while maintaining their strength. That means the severe weather threat is not confined to one single location. As storms move through the region, they may impact one community after another, bringing strong winds, heavy rain, lightning, and potentially large hail. In certain cases, rotating storms could also develop the structure needed to produce tornadoes. Another reason forecasters are concerned about this setup is the duration of the favorable conditions. Sometimes the atmosphere becomes unstable for only a short time before storms quickly stabilize the environment. But in this situation, several indicators suggest that the unstable air mass could remain in place for many hours. When that happens, storms can continue to develop repeatedly as the larger weather system moves through. This process can lead to what meteorologists sometimes call multiple rounds of severe weather. One group of storms may develop first, producing strong winds or heavy rainfall. Then, later in the day or evening, new storms can form in the same unstable environment. Each round has the potential to bring additional severe weather impacts. Forecasters are also closely monitoring how storms may interact with each other. As storms develop and merge, they can form larger systems known as mesoscale convective systems. These systems can produce widespread damaging winds that extend across hundreds of miles. In other words, the threat can evolve from isolated storms into a large organized storm complex capable of affecting a broad area. This is why meteorologists are watching radar data, satellite imagery, and atmospheric models so closely right now. Each new piece of data helps them determine how likely it is that this situation will escalate into a larger outbreak scenario. It is important to remember that not every favorable setup leads to a major event. The atmosphere is incredibly complex, and small changes in timing or temperature can sometimes limit storm development. However, when the ingredients appear as supportive as they do right now, forecasters take the threat very seriously. The key takeaway from this final lesson is that the atmosphere is showing several classic warning signs of a potentially significant severe weather event. Storms that form within this environment could strengthen quickly, become organized, and move across multiple areas as the system progresses. That is why staying aware of changing weather conditions is so important during situations like this. Forecast updates, watches, and warnings are issued to give people as much time as possible to prepare if storms begin to intensify. Over the next several hours, meteorologists will continue analyzing every update from weather models, radar systems, and satellite observations. These tools help track where storms are forming, how quickly they are strengthening, and which areas may be at the greatest risk. The atmosphere has clearly entered a phase where the potential for severe weather is increasing. Whether this situation produces a few strong storms or evolves into a larger outbreak will depend on how these atmospheric ingredients continue to interact. But one thing is certain: the environment is becoming increasingly supportive of powerful storms, and that is why forecasters across the region are paying such close attention to what happens next.